Ever heard that sound, when an ambulance zooms past and the siren kind of changes pitch?
Yeah, yeah.
That's the Doppler effect, and it's what we're diving into today. You guys send in some seriously cool stuff for this deep dive.
Definitely.
We even have an interactive simulation from Open Educational Resources. It's open source physics at Singapore
Oh, cool.
to help us really visualize this whole thing.
Yeah, it's a great way to get a grasp on the concept.
Definitely, yeah.
In the simulation, you can actually change the speed and direction of the sound, the source of the sound, and then you can see how that affects the sound for someone who's, say, standing still.
I love that, yeah, you can really see how those sound waves,
Yeah.
Whether they're getting compressed or stretched,
Yeah.
depending on whether that sound source is moving towards or away from you. And the cool thing is, this isn't just for sound.
Right, exactly.
This applies to light waves and radio waves, too.
Yeah, that's why it's so important in fields like astronomy, for example. Astronomers use the Doppler effect to figure out if stars and galaxies are moving towards us or away from us.
That's amazing.
And they can even work out how fast they're going, based on how much the light they emit is shifted.
So if, a star's moving towards us, its light waves are kind of squicked together, so it looks more blue.
Yeah.
And if it's moving away, the waves get stretched out and it looks redder.
Exactly, yeah. It's like the universe's own speed radar, but with color instead.
Oh, I love that.
And speaking of radar,
Yeah.
that's another place where the Doppler effect is, really useful.
Yeah.
Like the radar guns the police use, those use the Doppler effect to figure out how fast a car is going.
By bouncing those radio waves off it.
Yeah, exactly. And then they analyze the, the frequency shift.
It's wild how much we use this one concept. And it's not just about catching speeders, it's in medicine too.
Oh, yeah, for sure.
They use it in ultrasound imaging.
Yeah.
To see how the blood's flowing.
Yeah, by looking at the frequency shift of the sound waves that bounce back from the blood cells. And that helps them spot any, potential problems like blockages or abnormalities.
Wow. So,
Yeah.
It's actually super useful for a ton of cardiovascular stuff.
Yeah, absolutely.
That's incredible.
The simulation, by the way, works on pretty much any device, even Chromebooks, and it's in a bunch of different languages.
Really? That's amazing.
It's fantastic. I mean, this kind of resource is out there for everyone.
Yeah, it makes these kind of complex scientific things actually accessible and even fun.
Exactly.
And this one is actually made for secondary school and junior college students.
Wow.
So it shows how important this concept is even, early on.
Yeah, definitely. It's a great example of how technology can really make learning better and make science more interactive,
For sure. Speaking of interactive,
Yeah.
that's one of the coolest parts of this simulation. It actually lets you mess around with, different variables. You can change the speed or the direction the sound is moving in, even the medium it's traveling through.
Wow. Yeah, that's awesome.
So you can really see for yourself how all of that affects that perceived, frequency.
It's hands-on learning,
Exactly. And it's not just seeing it happen. It gives you all the explanations and visualizations of all the, underlying physics.
Yeah.
So it's great for deeper learning, too.
It's more than just a fun tool. It's actually educational. You can actually see those sound waves getting, squished or stretched as that source moves. It really helps you, wrap your head around the concept.
Totally. It makes me think, how do we even use sound to measure, a star that's so far away?
Oh, that's where things get really interesting. So we can't hear the sound from a star, obviously.
Right.
But we can observe its light. And just like sound waves, light waves also do this Doppler effect thing.
Oh, I see.
So instead of listening for a change in pitch, astronomers look for a change in the color of the light. It's like the universe has its own visual language, and we can understand it because of the Doppler effect.
That's so cool.
So by looking at the spectrum of light from a star,
Yeah.
astronomers can tell if it's moving towards us or away from us, and even how fast. And this has been essential for figuring out how the universe is expanding and how galaxies move.
It's incredible, right?
Yeah.
That something as simple as, a siren changing pitch can tell us so much about the universe.
It really shows how everything in science is connected and how one discovery can lead to a ton more knowledge in areas you wouldn't even think were related.
Yeah, it really makes you step back and appreciate just how much we can learn from, things we observe every day.
For sure, for sure. And this resource you sent in, it goes beyond just explaining it,
Right.
It really lets you get hands-on and experiment.
I was playing around with it earlier, and it's amazing.
Yeah.
You can actually see the Doppler effect, like right there happening. And you change the variables and you see what happens. It really helps you understand it better.
Totally. Yeah. It takes you from, knowing about it to actually getting it.
Yeah, exactly.
Like instead of just reading it in some textbook, you're messing with it, seeing it happen.
It's like, it makes me think, what if we couldn't measure the Doppler effect? Would we even understand the universe the way we do now?
That's a good question.
I mean, it's such a fundamental tool,
Totally. Yeah. Imagine trying to study the universe without knowing how fast things are moving, like towards us or away from us.
Right.
It'd be like trying to walk around a city with no map.
Exactly. Like, we wouldn't know about the universe expanding or how galaxies move. We wouldn't even know about exoplanets.
Right. All those planets around other stars.
Yeah, it would be a completely different picture.
So think about it this way. Okay.
When astronomers look at the light from a star, they can see these tiny, tiny wobbles in its movement because of the Doppler shift.
Oh, wow.
And those wobbles, they can tell us there's a planet there, even though we can't see it directly.
So it's not just about speed then. It's about, finding hidden things.
Exactly. Yeah, like whole other worlds out there.
That's incredible. And it's not just astronomy either, right?
No, not at all.
Like medical imaging. If we didn't have the Doppler effect, doctors wouldn't be able to use ultrasound to actually see how blood is flowing.
Right. Which is crucial for diagnosing and treating so many things.
It's crazy how something as simple as a change in pitch or color can reveal so much.
Totally.
I mean, from the vastness of space to the inner workings of our own bodies.
It's all connected.
The Doppler effect helps us understand the universe in ways we never thought possible.
It really does. And it all started with, Christian Doppler's observation back in 1842.
It's amazing. Just shows you the power of human curiosity and scientific inquiry.
Speaking of Doppler, do you think he could have imagined all this?
It's hard to say, but it's a perfect example of how a simple observation can lead to huge, huge discoveries and advancements and resources like this simulation we're talking about. They're helping to make sure future generations can learn from this and, build on it.
It's so important to make this stuff, easy to understand and engaging, especially for younger students who are just starting out.
For sure. For sure. I mean, this simulation does a great job of that. It makes learning about the Doppler effect fun, interactive. It helps you really get it.
When I first learned about it, it was pretty abstract, but seeing it in action, like in a simulation like this, it made all the difference.
Yeah. Yeah. It's about connecting the theory with the actual doing,
Exactly.
Like reading about it is one thing, but being able to play with the variables yourself and see what happens, that's a whole other level.
And this one's online.
Oh, yeah.
Anyone can access it anywhere.
That's fantastic. It's a perfect example of how technology can, democratize knowledge,
Right. It's not just stuck in classrooms anymore.
Exactly. Anyone who's interested can, dig in and explore.
And speaking of digging in,
there's
so much more to the Doppler effect. It's not just sound and light.
Oh, yeah. It applies to all sorts of waves.
Like radio waves, even water waves.
It's a fundamental principle,
Wow.
It's how waves behave in any medium.
It's amazing.
And the more we learn about it, the more we find ways to use it.
It's like science is always changing, always discovering new things.
Exactly. Yeah. It's exciting to think about what's next,
For sure. What breakthroughs are still out there waiting for us?
Who knows what we'll be able to do with the Doppler effect in the future?
Right. I mean, we've come so far from Doppler's first observation to being able to map the universe, diagnose medical conditions. All thanks to this one thing.
It's a testament to human ingenuity,
Definitely.
The power of scientific exploration. It reminds us that there's still so much out there to discover.
And that this simulation is available in so many languages.
Oh, yeah.
It's huge for accessibility.
Absolutely. It makes science education more equitable. It means that everyone, no matter their background, can learn and explore these concepts.
It's beautiful, how technology can break down barriers.
For sure.
And create a more diverse scientific community.
Exactly. It's about bringing in different perspectives, different ways of thinking, to enrich our understanding.
The more diverse, the better, right?
Absolutely. Yeah. Science is a collaborative effort. Everyone has something to contribute.
And that's why resources like this simulation are so important.
Yeah.
They make science more accessible, more engaging, and they inspire the next generation.
They foster a love of learning, a thirst for knowledge.
It's a reminder that sometimes the biggest discoveries come from the simplest observations.
Just like Christian Doppler noticing that change in pitch.
Which led to us understanding so much more about the universe around us.
Exactly. Science is everywhere, just waiting to be discovered.
It's in the things we see every day.
The questions we ask.
Curiosity we have.
And the tools that help us explore.
It's about the journey and never losing that sense of wonder. It really makes you think, what if we never had this tool, the Doppler effect? What mysteries would we be, totally stumped on?
It's a really interesting question to ponder.
Would we even be able to, predict the weather like we do now?
Well, think about Doppler radar.
Yeah.
It uses the Doppler effect to track how precipitation moves. It's completely changed how we predict storms, how we keep people safe.
Right.
Without it, forecasting would be way less accurate, for sure.
And what about in astronomy? What would we be missing?
Oh, man, so much. We wouldn't be able to confirm the expansion of the universe or understand how galaxies form.
Wow.
We wouldn't even be able to detect exoplanets, those planets around other stars.
It's like we'd be missing a huge piece of the puzzle.
Yeah, exactly. It would be like looking at the universe with one eye closed.
It's wild to think that something as simple as, a siren changing pitch as it drives by can tell us so much about the universe.
It really shows how everything is connected,
Yeah.
From the tiniest atom to the biggest galaxy, it's all governed by the laws of physics. And the Doppler effect helps us understand those laws.
It's been an amazing deep dive.
Definitely.
We've explored the science, the applications, and even what the world would be like without it.
And the resources you found, especially that interactive simulation, they're fantastic for anyone who wants to learn more.
Absolutely. So to everyone listening, be sure to check out the links in the show notes.
Yeah, play with the simulation, explore those extra resources, and most importantly, stay curious.
Keep asking those questions.
And the next time you hear that ambulance siren changing pitch, take a second to think about the science behind it.
It's a reminder that the universe is full of incredible things, and we have the tools to explore them.
So keep exploring, keep diving deep.
And until next time, stay curious.